We're gonna start a new project. This is the second part of my DVD. We're gonna create a toolpath. In our first part of our DVD, we just created a geometry. We created a whole bunch of solids and surfaces. And now we get into a more complicated programming part, creating the toolpath. CATIA, as well known, works with different windows at the time. So if you want to create a geometry, we're gonna have a different window which is called shape design, and we can work with part design. So we're not gonna have all of them all together. So for example, once we're gonna create our geometry or our surfaces, it doesn't matter, part design or shape design, then we can go to toolpath. What happened over here, I'm gonna teach you how to go to advanced machining. We have a couple of steps of programming. We have 2D, 3D, and we have a prismatic, basically that's a 2D, and we have surfacing machining. But advanced machining has got all of these operations that I just mentioned, 2D, 3D, all the 4 axes, everything has got it all 5 axes. It's all on this module right here. So if I'm going to show you how to use advanced machining, it's going to be so much easier instead of learning one thing at a time and getting all confused. So I'm going to start the advanced machining. So for example, let's make a quick part and a part design and create a quick toolpath on it. So what I'm going to do, I'm going to create a quick sketch just for the heck of it. I'm going to go to this option right here to create a sketch on this plane. And I'm going to create a quick pad. Click OK. And let's create a pocket over here. We can click on this sketch and on this surface. And we're going to create a quick pocket over here. We're going to throw some fillets. Let's go 1/2 inch deep. So we have a quick part, right? So like, for example, we finish the geometry and we want to make a pocket to machine this pocket inside in here. So what we're gonna do, we're gonna put start, and we'll go to advanced machining. And as you see right now, this is our axis, this is our part, this is all of our operations. And in order to throw our toolpath, our pocket operation in here, we gotta set up first the machine. What I'm gonna show you first, before we go any further, I want to make sure that I'm gonna give you a tool library that I already have, and we don't have to create your own tool library, and I'll show you in a minute what I'm talking about. So every time we start advanced machining, very first thing we have to set it up. So first thing is we double click on part operation, and we get our part operation window. So every time we have to get familiar and used to that. We always have to do this. Before I do this, I'm gonna cancel this for a quick second because I want to create my plane and my boundary box, my stock material. So I'm just gonna cancel this for one quick second. and I'm gonna go back to my part. So as you see right here, we got once I click on the part design, icons change. Once I click on the toolpath, icons change. So I'm gonna go back in here, or you can go Windows, switch back and forth. So I'm gonna go to part design for one quick second, and I'm gonna build I need a surface. There is one option over here that they will need to have on, so we gotta make sure we pull that out. So let's try to open some of those. I don't see it in here. Section, reconcile. I don't see it in here. Might be in the shape design. There we go, surface machining tools. That's what I was looking for. So let's go back in here and let's turn this option on. I'm gonna lock this again. This will allow us to create a rough stock material. So we can create it, or can we import the STL file. So you can click import, and then it's gonna ask you where you're gonna import it from, or you can create our own. So for now, I'm just gonna create our axis, and I'm gonna create this box right here. So this is gonna be my my stock material. I'm gonna make it 1 inch. So as you see how I got my stock material, so in real life it knows that this is my block of material, whatever it is. It can be aluminum, stainless steel, doesn't matter. So automatically create a folder over here. It's called a rough stock. So it knows it's a stock material. So right now let's go back to our advanced machining. Oh, by the way, we have to create, let's go back, let's create our reference plane. So let's create a plane. I'm gonna insert a geometrical set. I'm just gonna put it in here. And as you see, this is defined on the work object. So if I do defined, if I create right now a plane, it's automatically going to be created into this folder. But if I go define on work objects, everything that I'm going to create it from this point on is going to go underneath this folder. So I'm going to click on this plane, and I'm going to put offset from a plane. So we get a couple options we can choose from. And I'm going to bring a little bit above the part. Click OK. This is going to be my clearance plane. I want to make sure when my tool retracts, will go up to this point. So we got to keep this in mind. Those two things we have to create before we switch to advanced machining. We got to have the rough and the clearance plane. So now we can go back and advanced machining. We got our axis XY0. We can move our axis whatever we want. For example, let's say this is our part. We can move our axis in this corner. We can move it in this corner. As a matter of fact, let's do that right now while we play with it. See our axis system, it's automatically in here. It's a default. But we can create our own. So this icon down here is called axis system. So if you click on it, it's going to ask us X, Y, Z direction. So if you click on X, you can tell I want this X and I want this edge to be Y. It's upside down, but there's no problem. If you click reverse and you want Y to go the other direction, you just click reverse and watch what happens. We created our axis. But if you want to move it on the other corner, we go to a selection and say I want to put it on this corner. Or we can put the again origin and you can put it on this corner. or you can click here, you can put it on this corner. So whatever you feel familiar with, just move it in the right place. Click OK. Now, as you see, this became our default axis. It's all straight line, and this is a dotted line. So this is the active one. If you do a right click, you see over here is set. If you click set as not accurate, right now they're not, both of them, they're not active. So I'm gonna activate this because I'm gonna use this as my first operation. So I'm gonna go to properties, right click, go to properties, and I'm gonna call this my first operation. And I'm gonna turn this off. Go to right click, hide show, turn this off. So this is gonna be my XY0. Let's go back to advanced machining. And look what happened, because we didn't set up our XY, it knows my XY0 is right here. So we have to tell it that this is our original axis. Okay, so let's go back to part operation. We call it over here first op. And I usually like to put my machine name just to make sure I know what kind of machine I'm using. If you have any comments, you just put it in here. Now on the machine, we always have to make sure we go through all this before we click OK. We always have to do this. So let's click on the machine and let's make sure we say it's a 5-axis machine. Because if you don't click 5-axis machine over here, once you create a 5-axis geometry, 5-axis toolpath in here, once we're gonna make the code, we're gonna create our APT code. Our code is not gonna be a 5-axis code; it's gonna be a 3-axis code, even though the toolpath shows 5-axis. So we have to make sure we specify the right machine before we move forward. So we got the machine. On catalog, the thing that I just wanted to show to you, this is a whole bunch of samples. And over here it's got, for example, let's choose tool sample 1. And I'll show you in a minute what I mean. I'm going to give you my own library, so you don't have to use the sample one. It's already built up if you feel comfortable. Over here we use the kata comp. So if you use the kata comp, you turn it on over here. I was going to ask you, you have to turn this off first. So this is the kata comp in here. And numerical control, I usually use, also I have my own PP table for APT source because it's pretty easy, but if you feel comfortable, this always works the best. APT is the sample. So we're gonna leave it as a sample for now, and that's the only thing we change over here. This is the spindle home position, but the only thing we change is the tools. We have to pick up our library and color compensation and the sample of your post processor. So I always use the PP table sample, and your output is going to be a APT. Most of the best output, it's APT. And if you have a host machine, there are companies out there that will take the APT and they convert it into NC or whatever your machine can read. So for now, we're gonna just create APT only. Okay. So once we set all this, we're gonna click OK. So we just get out of here, out of our machine. Now we have to go next to create our axis. See, our axis right now it's over here, but we have to make sure we specify our new axis. So let's click on the axis and click anywhere on the red area. Okay, and it's gonna ask you to select your on the bottom left hand corner. It says select an axis, and we just click on the new axis that we just created earlier, and automatically it's gonna snap in place. And I always like to type in here, put a little bit of space, because I don't like to see all this in here. And I just click over here, first operation, top. Click enter. And this is our first operation axis right there. Click OK. We don't mess with this right now. We just leave this alone. Now we go to our part. We have to select our part because the reason we do this so we can watch the verify. So see, it says right here for simulation only. So we gotta select our part, which is in here. This is our part. Just highlight it and then double click twice over here so we get our window back. Then it's gonna ask us for the stock material, so let's click on the stock, and our rough stock is this. So click on this folder and double click twice on this empty area, and then it's gonna ask us for our safety plane. Click on the plane, let's come over here, and that's our safety plane. Position, simulation, options, don't mess with this now. It's way too advanced, and then we don't do any simulations with the machines and tool changes and all that. I pretty much leave those alone, those options over here. So once we set up our machine, we set up our axis, we pick our part. That's why we have to make sure every time we create our part, we have to make sure that this folder is the part only. That's why we have to make sure not to have a whole bunch of geometry on one folder. So if this is one part, let's keep it separate folders, because once we do the verify and we have, for example, on this level over here, we have a couple different parts, we got to get an error once we're going to try to run our simulation program. So it's very important that we keep everything in different folders and subfolders, and we're going to be very easy for us to click on them. And see, for now, for stock, we know what it is. Part, we know what it is, so it's very comfortable. Safety plane, we know what it is. So basically right now we're ready to create some toolpaths. So once again, this is where you create your machine. You have to tell it what kind of machine you use, what kind of tool catalog you're using. If you use a color compensation, and your PPT table, you got to choose it right here. So over here is our machine. Over here once again is our axis. If you have your own axis or different axis, make sure you click on this area, highlight your axis, type the part number in here or operation number in here, click OK. Then we go to part. We gotta define our part, which is right in here. We created a pad and the pocket, so this is our main part. Then we created the stock, which is right here. This is our stock. Then our safety plane is right here. So let's click OK. And for now, we don't need the stock anymore, because we want to see the pocket and the part much better. So we can turn this off by doing a right click, hide show. So we turn that off, and let's make a quick pocket in here. Now every time we create a operation, if you click on this, it doesn't know where to put it, so it's asking us for a reference operation to insert. So if you read down the bottom over here, it's always telling us what to do. So it's going to ask us, what do you want to put it after? And then once I click on this operation manufacturing program, automatically it's going to create my operation on the bottom over here. So this is my pocket. So for now I'm just going to do a quick I didn't select the tool, it's automatically picking the standard tool. So that's a quick operation right there. I'm just going to click OK for now. I'm just going to leave it like this. I'm not going to mess with any settings. I just want to make sure that we go pretty good to this first. So we just create a quick pocket right now. But what I want to do, for example, you want to create different manufacturers in here, right? So once you click on this, for example, you want to create more manufacturings. We got the same thing on the bottom right here. It says select a reference operation to insert a new one after it. So once we click on this, we get a new manufacturing program. So we can create. So click on it, click over here. So you can create as many as we can if you want to keep this organized. So if you want to have just pocketings over here, if you want to have only drilling over here, it's up to you. So for now, if I want to put let's say a facing operation, I just click on the facing, then I'm going to click on this manufacturing, and automatically it's going to put, see, my facing operation under this level. So I create a quick operation program. So I'm just fly cutting the top of the part. So that's how we create manufacturing programs. Now let's go back. I still did. I'm not gonna explain now how to use the pocketing operations only. Now I just create a quick and dirty just to show you pretty quick. But let's go just for the tools right now. So for example, see over here, I'm gonna minimize everything. We have on manufacturing operations, we have the process list, product list, and resources list. We always gonna work with resources and process. The product, it's all we create the geometry. So this is our part. All the toolpath and all the geometry goes in here. So we don't worry about this now. This gets created on the part design or a shape design. That's where this gets created. So those two gets created over here. All the tools goes under this right here. So right now we have a 5-axis machine. It goes in here. If you create another 3-axis machine, it goes in here. So all the resources goes in here. Product geometry goes in here, and the toolpath goes in here. So for example, right now we created this standard toolpath with the standard tool. Automatically it picked up this tool on its own. It's a default tool because we've been using the sample table. So let's go back in the pocketing. Let's go to the tools and let's see what kind of tools we're using over here. So we can click here and it's telling us that we use tools sample 01. We can switch this and then see we get different kind of tools in here. But they're not they're some odd numbers. 787 diameter, ball and mill, 393. So they always got some weird numbers. I don't know, it's nothing, it's inches like the way I want it. They have a whole bunch of stuff in here, but it's not not the way I want it. So what I did, I have a tool library. We can load it in here, and we can open my tool library. So every time we're gonna set up these operations, we're gonna come in here and pull up my library, and then that way it's gonna be much easier for us. So let's go, before we move forward, let's go put my tool library in here. So I'm gonna cancel this. See, look at this tool number, it's 393, and I'm not gonna use this. So what I have over here, I have my catalog tool library. So what I'm gonna do, I'm just gonna copy this file, and I'm gonna paste it in the folder with the manufacturing where CATIA is at. So if we go to program files, Dissolve System, B17 folder, Intel A, Startup, Manufacturing Tools, and if we paste it in here, we're gonna use my library. So right now let's go back to CATIA, and let's go back to our operation setup. Let's go back to machine, and on the numerical control, last tab, no, on the tooling. Let's go on the tools catalog, and then we should be able to see SAMI tool library. So let's click OK. Let's go OK over here, click OK, and let's go back to my pocketing operation. And let's go to the tools, and let's see the difference. See how nice and organized the tools are? So we got 1 inch, flat bowl, flat bowl. So this is much better. So you can choose your tools from here. So you can customize it. You can create your own tools and save them to the library. But for now, this is pretty good. This is standard diameters. And for example, let's say we want to choose a 1 inch flat. Let's click on 1 inch. 1 inch bowl. 3/4 flat. Click OK. And you can customize it. Even my operation, even though I said it's a 750, for some reason it puts this radius in here, but you can double click on it and make it 0, make it a sharp corner. And you get your tool over here, customize. You can put the tool length in here. Let's make it 2 inches, 2 inches, and let's make the holder 2.2. That's a standard size. And over here, the tool number 1, it's telling us that we already have a tool number 1, so it doesn't like to have two tool number 1s. So if you click OK, I'm going to recompute this, and as you see right now, this is our new tool. And I'm just going to come back in here, click on this tool, click delete, and get it out of there because we don't use it anymore. I'm just going to double click back on this, go pretty quick through a couple options in here. So those are the tabs that you can select: tools, operations, lead in, lead out, feeds and speeds. So for example, right now it has outward, helical. You can put inward, it changes the position, or back and forth. It's a zigzag. Now you can put over here climb. See, it's got the little arrow, the question mark over here. So if you click on this, if you don't know what this stands for, just click on this and we'll let you know. See, this is the rotation of the end mill. So the end mill rotates clockwise, and it's moving forward this way. See the arrow going this way, and the tool rotates this way. So everything is climbing. So I'm pretty sure that all the programmers that is out there, they know that most of the programs, they need to be climbing. Rare we find programs that we get a nice finish using conventional. So I very rarely use conventional. I always leave this on climb all the time. I never change it. Over here is the tolerance. You can see over there. Radial. It's asking us over here the tool diameter. So you just put over here your kind of like a step over. So right now it's 50%. So the step over ratio is 50%. Or we can put to distance. So right now we put step over 375. Step over from here to here, we get 375. Or we can put the step over ratio or maximum distance. They show you right here the difference. But I like ratio the best, 50% of the tool. Then we have radial was going sideways, as you see. Axial goes up and down. So it's asking us how many depth of cuts do we want. So just click on this and it will tell you 1, 2, 3, 4. So let's say we want to cut this 3 times, and let's make the depth of cut. We cannot select it right now, but if we change this to numbers of levels without the top, because we didn't select the top yet, we just put without the top right here. So now it's gonna tell us, okay, this right here stands for the thickness. So we put 200 over here and 3 times. It's gonna ask us if you want to make any finish passes. We can say yes, make one finish pass at last level. So you click on this and it will show you what it does. Green is the last pass, so it shows us it's going to finish the bottom and the wall at the bottom. So it's asking us for the thickness. So the thickness from here to here, we want it 20,000. Then it's going to ask us number of side finish passes by level. So it's going to ask us how many passes do we want. It says 1, bottom, thickness, and side finish pass. Side, thickness at the bottom, everything is common sense. And then if you don't know what it does, you just click on the question mark. See bottom finish. Let's make this 20,000. So right now I just give it a finish on the bottom and a finish on the wall. If you want to put the spring packs, just click over here. Composition output has got none. You can put if you want to put color comp, you just click on a 2D radial tip or profile, whatever is convenient. And over here is going to ask us the floor, where's the floor, and the contour. And what is the top? See, when it's green, that means it's already selected. If it's brown like this, it's not selected. So right now I gotta put my top of part, it's over here. So now you got green also. And you have a couple options you can play with. So you can put open pocket, close pocket. So in our case, this is a close pocket. It's gonna ask us the offset on the boundary, offset on the contour, offset on the bottom, how much you want to stay away from the bottom, from the contour. And if we have a clamp over here, we can put the dimension on a check surface. Now this next tab over here, it's selection of the tools. So to select the tool, once again, you just click on a select a tool, and automatically it's going to pop up the library that we just inserted. This is our custom SAMI tool library. What I'm going to do, I'm going to copy this file into the DVD. And if you have, you guys have already CATIA, maybe you can copy and paste it. I already show you the location. And so you'll be able to get this nice library in here. So click whatever tool you want, and then you click OK. Then you get a tool over here, and you can customize it, the tool length if you have radius, and also you can change diameter. You can change it to 700 if you want. Okay. So let's go next. Next is our speeds and feeds and speeds. So let's say we want to approach the part at 20 inches. Yeah, I was trying to put inches. Sometimes it recognizes that, but I'm just gonna make it 20. It says 20 millimeter, but once you're gonna post that out, it's gonna be 20 feet rate, which is gonna be inches. Retract, I'll make it 100. Let's go a little faster, 50 feet rate. And this is our RPM. So for the 3/4 end mill, if we have a carbide, we'll usually go around 6500 RPM. And let's put the quality of this program finish. We want to look a nice finish to this part. Let's go to the last tab, feeds the way we lead in and lead out into this part. So it's asking us over here, approaching, retracting from the part. So let's say approach from the part. We want to ramp once we're gonna come into the part. So we go here, click on the ramping, then we go to build by user, and we can put a add axial motion up to a plane. So what we want to do, we want to come from this plane that I just created, come down, and then ramp it into the part. So I'm just going to click on this, and automatically we get this rapid and the plane. So I just click on this, and I'm going to select my plane, and automatically knows on the macro that this is my plane. We also can edit this 394 ramping distance. You just double click on this, you can change it, for example, 250, and if you double click on the ramping, we can change this length. For example, we want to make it a little bit bigger, so we'll make this 500, half inch. Vertical distance from here to here is 250. Ramping angle from here to here it says it's 20, we can make it 10. Let's click OK. So this is our ramping. Now retracting, we just said you can create as many as you want, but if you made a mistake, you just can delete them all. So I'm just going to make only one rapid to my clearance plane. So I'm going to ramp in and wrap it out once I get out. But see, right now we have approaching to the finish pass, retracting from the finish pass. So to activate those guys, you just do a click on it, then do a right click and active. And automatically, you see over here they get yellow. Once we define this and recompute it, they're going to become green. So right now I'm going to deactivate those two guys. I'm just going to, before I get too complicated, I just want to go a little step at a time. So as you see right here, we got our ramping, which is huge. We can take it down a notch if we want to. So this is our ramping that will comes here. We can view this step by step. So we can rewind, and if we click right here, which one is it? I think it's this guy. So if we go step by step, we can see every little step what the part is doing. So it ramped into the part, the one here, so we can see every step of the way. But if you want to jump 10 steps at a time, we just click 10. So on each click, see it jumped 10 steps at a time. So this is 10 steps. And if you want to play it normal, just go back to this. Let's rewind it and click play. And this is our pocket. Now if we want to watch the demo, the simulation, that's why it was very important when I first started. We have to define our stock material. We have to define this stock. We have to define our safety plane and the part in order to use this. So right now if we click on this, we have a couple options. I'm just going to click on this right now so we can see this is our part that we just defined. This is our stock material. So if I click play right now, we can see the tool coming in there and machining the pocket. And what we can do, we can save this. We can save this result and can pull it up later, and we can keep on going from there. So I'm going to keep this. It says it's already stored. Click OK. I want to click OK over here, and over here on my pocket we get this blue mark, and it tells us that we already have a previous operation stored in there. So we can change this as much as you want. Just double click on it. We can change it instead of back and forth, inward. And right now, because we selected the top, we can go back over here and on axial. Remember, we just selected the numbers of levels without the top. We can put the maximum depth of cut, and it knows that our top is over here.